Right, so I'm going to be really quick. Thanks for coming, everybody. I was looking at this on the train and I was thinking, you know, this talk for this brilliant audience here of amazing functional programmers is going to be fairly boring, but luckily it's only going to be about 5 minutes long, so, and then everyone can go to lunch. But I think this stuff, although for you guys it's boring and kind of obvious, for 99% of the programmers out there who don't know about functional programming, this stuff is, they look at this stuff that I'm doing, and even though it's really simple, it's rocket science for them. And we do actually have a logo as well, which I drew. Alright, so let's... So what I'm going to talk about is how we are using OCaml to generate 206,353 lines of code, mainly C code. What we're doing, and this is slightly off the screen there, is defining the API for this large library that we wrote. As you can possibly see here, we've got the pointer. Green button. As you can see here, each function in our library is named, return value, parameters, and a bunch of documentation there. That one description there turns into about 400 lines of code. So from that we generate back-end RPC stuff, we generate bindings in OCaml, Perl, Python, Ruby, Haskell, Java, and C#, which is in itself another story. Which of those is the best language to write bindings for? We take a very aggressive approach, so we generate absolutely everything from this one small description. And anywhere in the library where we might have to write something twice, we don't. We write it once in the generator and we generate code for that. Now I'll show you quickly what this code looks like. Just as I say, there's an awful lot of it, but I'll show you a little bit of it. This is for a different function, but you can see here that all of this code is generated. The aim from generating the code is to write code that looks like you could have written it by hand. Okay, so you can read this code, programmers can read this code, and if there are bugs in it, they can find them. And then when you find bugs, you go back to the generator, you fix the bug in the one place, and then every single API function is fixed for you. Very different style from the normal way that people, for example, write bindings to libraries, where they handwrite every single thing. And I'll just show you very quickly what this code looks like. This is the generator itself, and as I say, this stuff to you guys it looks very boring. I mean, this is just where it's loops, it's printing, it's simple iterations, and it's lots and lots of these case statements. Is an argument a path, a device? It's turn it into a string. Is it something else? But this code is, as I say, for other programmers quite miraculous because it's so compact, and yet it uses some familiar things like C-style printfs. It's miraculously typed at compile time. I mean, this feature is amazing because there are no types in it. How does that work? So I think what my point is here, and I'm going to finish up now, is the message here is that we need to get this stuff out. Functional programming is fantastic. It's a really amazing sort of almost rocket science for many programmers out there, even though for you guys in the room it's like very ordinary and very average. So we need to get out this message that you can do amazing things in OCaml and other functional languages. So that's all I'll say.